asked to solve an equation that involves fractions, the best thing to do is to find the common denominator and multiply everything by the common denominator. That'll get rid of the fraction. In this case, we have 8, 5, and 10. We're looking for the least common multiple of 8, 5, and 10. If we wrote them out, 5 would go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 8 would go 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, and 10 would go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm looking on this list, all three of them, to see what appears on all of them and the lowest number that appears on all of them. That would be 40. So once I've identified 40 as what I want everything to have as a common denominator, I multiply the entire equation by that common denominator of 40. When I multiply it by the first fraction, it's being divided by 8. 40 divided by 8 gives me 5, which is being multiplied by x plus 5. When I do 40 divided by 5, that gives me 8. With that negative sign, it really means negative 8 is being multiplied by this x plus 3. And finally, when I do 40 divided by 10, I get 4, which means 4 is being multiplied by this x minus 5. So now I'm doing distributive property. 5 times x gives me 5x. 5 times positive 5 gives me plus 25. Negative 8 times x gives me negative 8x. Negative 8 times 3 gives me negative 24. 4 times x gives me 4x. 4 times negative 5 gives me negative 20. First, I'm going to clean up the left side by combining like terms. 5x and negative 8x combine to give me negative 3x. 25 and negative 24 combine to give me 1. So I'm left with negative 3x plus 1 equals 4x minus 20. I'm now going to take x's to one side, numbers to the other. So plus 3x here, plus 3x here, plus 20 here, plus 20 here. 3x's and the 20 go away. 1 plus 20 is 21. 4 plus 3x is 7x. So what I really have, I'm going to put up here in the corner, is 7x equals 21. If I divide both sides by 7, that's how I get my correct final answer, x equals 3. The key skill here is identifying the common denominator between these, multiplying through by the common denominator so I can solve an equation that doesn't have fractions. Question 24 is one of these problems where I have two different people who can complete a task in a set amount of time. The way you want to set up these problems is how much they finish in a single unit of that time. So if Mr. Moulton can complete baths for all three of his kids in 20 minutes, that means it takes him 1/20th of a minute to complete the task. Mrs. Moulton can do it in 15 minutes, so it takes her 1/15th of the task is complete in 1 minute. Total, we complete 1 over x of the task. So it's always going to look like this, where it's 1 over the first time period plus 1 over the second time period equals 1 over x. In order to then turn this into something without fractions, you just multiply by 20 times 15 times x. Basically, all three of the denominators multiplied together. The 20 will cancel the first one. It'll be 1 times 15 times x, or 15x. 15 will cancel in the second one. It'll be 20 times x times 1, or 20x. Finally, the x's will cancel, and they'll be left with 20 times 15, which is 300. If I combine like terms on the left-hand side, that gives me 35x equals 300. The last step is just divide by 35. When I get x equals 300 over 35, that's definitely not something I can do in my head. So I'm over here trying to find my calculator. Once I get my calculator, I can put it in. Here I'm going to put in 300 divided by 35. It gives me 8.57. Be careful and make sure you're paying attention to how many decimals they tell you to round to. Also remember that the digit that you're dropping does impact the rounding. If you're dropping something 5 or greater, you need to round up by 1. If you're dropping something 4 or less, you can just drop it. Number 25 asks me to use prime factorization to simplify the root. In this case, I'm looking for the biggest perfect square that goes into 243. So I can get out my piece of paper with my perfect squares and cubes, go to that perfect squares list, start by trying to put in 144, doesn't work. 121, close, doesn't work. 100, doesn't work. 81, does work. When I do 243 divided by 81 on my calculator, it tells me 3. That means this breaks up into the root of 81 times the root of 3. The reason we wanted the root of 81 is because it is a perfect square. When I take it out of that perfect square, the root of 81 just becomes 9. So I'm left with 9 root 3 as my simplified root. In number 26, it's asking me to do the same skill except then to combine with the second root. So again, I start by taking out my paper with all my perfect squares. I look at the first one that's smaller than 45, so 49 is bigger, I don't have to worry about it. 36 is the first one I do have to worry about. 45 divided by 36 doesn't give me a whole number. Divide by 25 doesn't give me a whole number. Divide by 16 doesn't give me a whole number. When I divide 45 by 9, I do get a whole number, specifically 5. So this breaks into root of 9 times root of 5. This is the perfect square. This is the part that will be left behind. If you figured out properly the first one, you want to try what's left behind in the second one, and it should work, because really in the end this problem should be designed to give me 2 of the same roots left over. So if I were to put 5 into 20, 20 divided by 5 gives me 4, which is a perfect square. So that is the correct way to factor this second part. Root 9 is really 3, so there I have 3 roots of 5. Root 4 is really 2, so there I have 2 roots of 5. 2 plus 3 gives me 5 total roots of 5. Number 27 asks me to solve an equation where I already have a root on one side, a number on the other. I do want to be careful. If this had been a negative number, I'd need to stop there and say no solution. Because it's a positive number, I can do the next step, which is just squaring both sides of the equation. When I square a root, those are inverse operations and undo each other. So just what was under the root comes out, in this case x plus 2. When I square 4, it's like saying 4 times 4. That's how I get 16. To finish the problem, I subtract 2 from each side, and I get my final answer of x equals 14.